So this is the circuit that is the vibration detector, which will detect the vibration in the environment. For this we are using this vibration detector over here in the top. It is SW420, which has LM393 voltage comparator to detect the variation in the output over a particular threshold point of voltage, because it's a voltage comparator. And this vibration detector is actually quite cheap, because unlike other acceleration detectors and earthquake detectors which can be used, it does not measure the difference or the change in acceleration or the speed. Rather, it just measures the vibration, so it's available at relatively lower price. So the output of this sensor is produced as analog output, so it is connected to the analog pin only. It's connected over here in analog pin number 5. So when in case the circuit is working normally, or if it is in steady state, the LED, that the multicolor LED that we can see right there over here, would be glowing without any interference, and everything is in off state other than that. But in case if there is some kind of vibration or some kind of shake, the multicolor LED will stop glowing, and the red LED adjacent to it will start glowing, and the buzzer which is connected to it starts glowing. So this particular sensor that we can see has always one light that would be glowing, but when I touch it, one more red light would be glowing along with it. As soon as the pulse gets stopped, the multicolor LED continues to glow. So for making this particular circuit, all you would need is one Arduino board, Arduino Uno, 125 volt buzzer, two LEDs of different colors, and the vibration sensor connecting wires. That's all, and the cable to connect the Arduino to the laptop or the computer. Okay, so now we are going to be seeing about the code that we are using for this program to run. So we have defined on as 1 and off as 0, which is not really necessary, but we have done it in this case. And the vibration sensor input, we have set it to analog pin 5. As I already mentioned, the output of the vibration sensor is going to be of analog data. We may have this question of why. Digital sensor produces output of either on or off, 1 or 0, which will be useful for things like the LED or things that can either take the on or the off value. But in this case, the vibration sensor is going to, give the voltage that is measured as the output. So voltage or the potential that is measured. Therefore, we cannot have a rigid on or off state for that. So we are going to use it through the analog mode. Then I'm setting the LED pin to 13, and I'm setting the another LED which glows always as steady, and I'm setting its value to be 12, and present condition and previous condition, which measures the two conditions of the particular vibration sensor, and I'm initially setting it to be 00. So I'm setting up what will function as what in this particular circuit. So the vibration sensor is going to function as the input or the sensor, and the LED and the steady state LED both are going to function as the output or the actuators. And I've just written a small function for making the LED blink. You can actually write it in over here also, but I've just written it out. In case you're using it as a function, you can call it any number of times, but anyway, we are just calling it once. So for this void function, the input is also void because we are not supplying any input for this particular function. We are writing the LED to be on, then after a time delay of 250 milliseconds, it's again going to go to off state, then on and off. this is the particular pulse that we expect to receive in case the sensor receives a vibration. And this is the main loop of the particular program. So when the previous condition is equal to the present condition in normal state, the led that is the led and the buzzer will be in the off state. And if present condition is measured by the digital read function from the pin A5, that is analog 5, which is where the vibration sensor is connected. And if the previous condition is not equal to the present condition, which happens in case of a vibration, the steady state led is turned off, and this led is going to be turned on by the calling of this function. Or else when it's already, or even it's always when the previous condition is equal to the present condition, and when there is no variation in the present condition reading from the digital read function, the steady state led will be on and the digital led will be off. Can I run the code here? We don't get any output because we have not printed anything, but we get this fully functional circuit. So thank you. I'll roughly go through the circuit once again. So this particular LED is connected to pin number 12, which is over here with this orange wire, and this LED is connected with the yellow wire to pin number 13, which will be triggered only when there is a vibration. And the same way this buzzer is also connected to pin number 13, and both the negatives of this LED as well as this LED is connected with the white wire over here to the ground, that's over here. Then for this, the DO pin will be connected to A5 from where the data is read. Then VCC is connected to the 5 volts and ground is connected to ground. That's all it's all about.